Alright, hello. Before I get into the nuts and bolts of finding the equation of a tangent line and finding the equation of a normal to a curve, I would like to point out that I created a Desmos normal and tangent finder for you. Here we could put whatever we want in for our function, and then we can take whatever we want for our a value, and that's going to change, of course, where the tangent and normal exist. So whatever I choose for a, the computer is going to draw a normal line and a tangent line, and we can use these normals and tangents to check our answers. I'll explain. In the haiku page, the haiku page might look different by the time you watch this video, but generally speaking, in your haiku page, I have the notes on tangents and normals. I have the examples that I'm about to show you are right here, and you'll also see right here is the link that will get you to this magic calculator. And all you have to do is to take your given equation and replace it with this, or replace this with the given equation. You replace your a value with the value of x that you're trying to find the tangent and normal, and your graph will be revealed for you. So let's see how to use this. I'm going to look at a situation where we're given a function and we have to find the equation of the tangent and the normal when x equals 4. So I went to my tangent and normal finder, and it drew me this blue line for the tangent, which has a positive slope and a y-intercept around -1, and I've got this normal, which has a negative slope and a y-intercept that's above 11. So now I know what I'm looking for, and now I have to find it. In order to find the equation of a line, we need to know a point on the line. Well, that's easy, 410. And we need to know the slope of the line. Since we're dealing with slopes and calculus, that tells me we're probably going to need derivative, which is correct. So the first thing I need to do is to find the derivative of the function, also known as a slope function. And first I need to do some cosmetics to make the equation more differentiable. So I get rid of all the radicals and turn them into exponents and clean it all up. Then I apply the power rule and clean that up. Simple as that. Now that I have the slope finder, if you will, I just have to evaluate at 4. Notice my notation. We need to find the slope of the tangent and the normal. Watch how I show the tangent, dy dx at 4. So this is dy dx, a general form equation. This is dy dx at, with the big line here, at 4. So everywhere there was an x, I replace it with 4 to get that the slope of the tangent line is going to be 11/4, or 2 3/4, almost 3. It's consistent with what I see here. A slope is really steep. Now, for the normal, I'm going to take the opposite reciprocal slope. So instead of dy dx, I'm going to write negative dx dy. So you notice it's reciprocated, that is, the fraction is upside down and opposite. So that's the opposite reciprocal of 11/4 is going to be negative 4/11. So once again, try to emulate this notation as you do your work. They're opposite reciprocals of one another. And finally, to find the equation of the tangent line, we need to use this format, y minus y1 equals slope times x minus x1. That's the point-slope formula. I need to find the coordinates of the point, so up here I evaluate f of 4 into the given function to get 10, which is shown on my graph at 410. And so, in my point-slope formula, I put y minus y1, which is the 10, equals slope, which I found using my derivative, times x minus x1, which is the 4. Then the rest is just a little algebra cosmetics, and I get the following equation. Notice that if I actually looked at my line and I went over 4 up 11, I'm back on my line again. So that is to say, from here I went down 11 and back 4, and I ran right into the line's y-intercept at -1. So my graph and my equation here, they check out. But I'm going to check that again a little bit later, but hold on. Now I got to find the normal, same deal. Y minus y1 equals slope times x minus x1, where the slope this time is negative 4/11, and I get the following: 11 and 5/11. Here it says 11 and 6/11. That's a typo. Nonetheless, it's good enough for me. So these two equations are the one the tangent and the other the normal. And just to make sure everything's copacetic, you'll notice that I took my normal and tangent finder, and I actually have the computer will type in the exact normal, and I take my answer, which is right here. That's the tangent. And they actually match each other. And here's the computer's normal, and here's my normal, and those actually match each other as well. So that's the complete way to check your answer. This one looks intimidating because it's all trigonometry, but if you have calculators and you're in radian mode, there should be no problem. But the first thing we need to do is find the slope function. That's the derivative. Then we need to find the slope at the given value for x, which in this case is pi over 4. So I use my notation, I write in the x equals pi over 4, and if I don't know how to do this by hand, I use a calculator, and I get 4. The opposite reciprocal of that is negative 1/4. I'm also putting 1/4 or pi over 4 into my equation to get the y value that goes with it. That was already done with my computer, but I'm showing how it works. Now I need the equation of the tangent. I have the point pi over 4, 1, the slope 4, so I use those to get the equation of the line. And for the equation of the tangent line, I use negative 1/4 and the point pi over 4, 1. I know I went through this really fast, but it's the same process as I showed you just before. The only difference is we're dealing with different numbers. At this point, though, if you want to pause the screen and make sure you understand everything that happened here, again, same work that you saw before. Last but not least, again, it seems intimidating with e to the x, and it's got natural logs in it, but that doesn't change the fact you got your technology, you know what you're looking for. You take the derivative, you evaluate the derivative at the given point for x, you take the opposite reciprocal to get the slope of the normal, and find the coordinates of the point, use point slope formula, get the tangent line, the rest is all cosmetics. Once again, after this is done scrolling out for you, I would encourage you to pause the screen, or at least look at the notes that I showed you on Haiku, and you can get this all right. But you can see, finding the equation of the tangent and normal is really a very routine, very algorithmic process. The places where you're going to get hung up, some people will struggle finding the correct derivative, some people will struggle cleaning up the equation of their lines. But the important thing is that we're cross-referencing with our technology as much as humanly possible so that we make sure that we're catching all of our mistakes along the way, instead of doing it all at the end and finding that it was all wrong. So, anyway, thanks for watching. Have a good day. Oh, before I finish up, I will say one last thing, and that is this work is also on the Haiku page that I showed you earlier. In fact, you can find it here in these notes. And if I was to scroll down, which I'm not going to, you'll see on one of the pages is this. Can't remember what page it is, but you'll find it. It's got 3 greens and 2 blues. So these are some extra questions that go a little bit beyond just finding the equation of the normal or the tangent. And so this is what I'd like you to work on until I come back. Thanks for watching.